than 0. And we'll gradually move into it. I heard one student and another student talking about this one, this particular type. Guys, it's not a quadratic. It's not one of those you're going to factor and all that business. And it does not look quite like what we were doing on Monday, but yet it's an inequality. Now, I could stand here and you could sit there and we could randomly start replacing x by numbers here and see what might satisfy this. Just at random, if I replace x by 1, I would end up with -3 over 5, -3/5. Is -3/5 greater than 0? No. So my random number I chose, 1, will not work. Well, maybe you say, well, Professor, what does work? Have you given us something where nothing works? Let me try 6. Just at random. Put a 6 in there, I get -3 over what, 10? That's a -3/10. Is a -3/10 greater than 0? No. Well, what's going to work? Or maybe just randomly, I'm choosing the wrong numbers. Does anyone have one at random that I could replace x by, and it might work? Does anyone have one?
Negative
No.
number?
Maybe like a negative what?
Mm-hmm.
Negative what?
-1.
Negative what?
1.
-1. Put a -1 in here. So I get a -1, that's a -1 plus 4, that's a 3. -3 over 3, help me out, -3 over 3, is that a -1? Is -1 greater than 0?
No.
I still haven't found one to work. Yes?
-5.
Let's try -5. I put a -5 right here, -5 plus 4 is a -1. A -3 over a -1, a negative over a negative turns into a positive. So I've got 3 over 1, that's a positive 3. Will that finally work? You think we can sit here and just randomly start choosing numbers and say, Professor, the answer is, I think he gave me, remind me of that number we just checked. What number was that?
-5.
-5 works, Professor. There's lots of others that will work. But do we have the time to sit here for 3-4 hours and randomly choose them? No, there must be some way to find them. Algebraically, fairly quickly. Now, I thought about this, like I said, when I was driving home after class. Can someone tell me, look at it closely, that is a fraction. No doubt that is a fraction, a numerator and a denominator. I've already set the numerator to be a negative, -3. I want the entire value to be positive, greater than 0. If I already have a negative up here, which I can't change, what must I force this to be if I want the whole thing to be positive? X plus 4, that denominator, has to be that. You guys agree? Just a rational thinking there? Must that bottom part also be negative, so I'd end up with a negative over a negative, which turns into what? Positive, and would satisfy this. So sometimes just looking at something, all of a sudden you see what's happening here. If I go ahead and solve this part here, guys, x is less than, what is that, -4? Are you kidding? Based on just mere observation. He gave me -5, I think, right? And -5 is one of these. Now, guess what? Anything else less than -4 should also work. He gave me -5, -6 should work. The -100 should work. All those numbers to the left of -4 should satisfy this. I'm going to try it right quickly, just at random. -10. So I put a -10 in here, -10 plus 4, I think it's what, -6? A -3 over a -6, a negative over a negative is a positive. 3 over 6 would reduce down to what, 1/2? So I got a positive 1/2. Is positive 1/2 greater than 0? This is the answer. Anything less than -4. In interval notation, be careful, looks like this. A negative infinity up to a -4. Guys, could I include -4? Should I put a bracket on that -4? What's wrong with that?
That makes it 0.
Yeah, if x were a -4, that makes what, 0 denominator? And I can never have a 0 denominator. There's the answer. Now, I guarantee you, if I say, okay, for a quiz, I've got 40 students, let's say. Let me start with student number 1. We'll go all the way through the class, and I'll ask my students, please give me a number less than -4. And if I had the time, I would check it for you. I guarantee you it will work. Student number one may say, Professor, I'm gonna try -10. Go for it. Guarantee you, it's gonna work. Next student may say, Professor, my choice is -25. I'll try, guarantee you, it's gonna work. So if I satisfy that inequality, it's gonna work. Okay? So I thought I'd bring that in just to lead me into where I'm going. Part B. Let's sort of go to where we want to go here. Next one looks like this. 2 over x plus 1 is less than or equal to 3 over x. Now you saw me do this one. I have a plan when I start teaching. I'll just come in like some, just randomly throw things on the board here. Can anyone tell me now, the next one looks like this, what might you tell me to do first? Before I really seriously start thinking about it. I see something I should do first in an attempt to get started here. Yes?
You could flip them to the reciprocals and put the sign.
You could, oh, I got you, you could. Something else I want, I follow you. Something else though, based on what I did over there. What do you think it might be wise to do first? And that's why I did that first problem first. What do you think might be wise? Yes?
Subtract 3 over x.
Move that 3 over x over. Subtract it. Now, with his help, look at this. Does he now have that critical 0 that I need? Now he has that 0 I need. So that tells you right now, we're not finished yet. That says now when you clean this up, we're looking for numbers that will make this less than or equal to 0, negative or 0. Now I need to do a little cleaning here though, simplifying. What would you suggest now on the left-hand side? Mine looked like this, it was nice. What would you suggest I do on mine? Over here. It's not really nice right now. What would you suggest I do on the left? Yes?
Make the denominators the same.
Thank you. A common denominator. And that common denominator, guys, will be x times x plus 1. And I need to make both those x times x plus 1 that common denominator. Here we go. That means this one's going to be multiplied by x. It's missing x. This one's missing the x plus 1. Don't make math hard on yourself. Just jump into it. Now see what's going to happen here. On top is 2x, the numerator here. I'll just bring it down. And I got subtract on the top of the second numerator. Looks like this. And still this. You guys agree? Now it's looking more, pretty soon it's going to look much like this one. It won't be the same problem, it's going to look better. To simplify further, we know what to do from algebra. This is 2x. Distributive property will be a negative 3x. Subtract 3 all over this. And you got this. You guys agree? Combine like terms, I'm going to stick with this step here. Combine like terms, I'll see a negative x. Subtract 3 all over this. Now watch carefully. This is so much moving into calculus here soon. I just combine like terms. I got that over my common denominator. And guys, write down, block this off. Does this at this moment, does it more simplified? Does it look more like what I started with here? It did not at first. I just cleaned up, simplified. Now I got the 0 over there that was suggested by a student. And then I cleaned it up, and we'll stop there, and now attempt to solve it from there. Not as easily solved as this one. Now, this is where that sign analysis, the powerful method, is going to help me out here. I didn't need it really here on this one. Go to a number line. This is the way sign analysis works. Can anyone tell me, based on what you see here, what do you think I'll be placing on my number line for my so-called critical numbers? And then I'll start testing to see where to shade. Yes?
0, 3, and -1.
I got 0 now. She says 0. Guys, where did the 0 come from? She says, Professor, right here, if you take this right here and set it equal to 0, it is 0. And then I think also x plus 1, since she told me to do that, write x to it, solve it. Oh, there's another critical number to work with. So 0 is 1, -1 is another, and I cannot leave out this. This also has an x in it. So what critical number could I suggest from that? Well, let's set it equal to 0, like we usually do for equations. Guys, solve this with patience. I think you get x to be what, -3? And that means I'm going to go down a little further to a -3, and those are my so-called critical numbers. This is sign analysis. You're looking at the signs here pretty soon. Now, it's up to you. You saw me do a sign analysis Monday. You got to test something here to the left of -3. You got to test something in between, and here. And whatever works, you get to shade. Guys, I don't care what you test to the left of -3. If you want to try -1,000, go for it. I'm going to try -5. And I'll come back to it. In between these two, I'm going to try -2. In between these two, maybe awkward, but we'll try -1/2. Just choosing a number. Out to the right of 0, my goodness, lots of numbers. I'm going to try 6. And those in the red down there are up to you. Now what am I going to do? I'm going to test them right here. Now watch carefully. This is not that hard, but just watch carefully. Guys, here goes. I'm not going to do the arithmetic. -5. If I replace x by a -5 right here, this becomes a +5. That's a prefix of a negative. So it's going to be a +5, subtract 3. That's a 2, but I'm more concerned about the sign. It's positive. My denominator, if I replace x by the -5 down there, is just the x. That's a negative, of course. And in the other factor, x plus 1, replace x by -5. -5 plus 1 is, what, -4? Another negative. Looking so much like calculus. From algebra, what is that? Altogether, you've got a positive over a negative times a negative. And what's a negative times a negative to begin with? Positive. You got a positive over a positive, which gives me a positive. You say, oh, Professor. And you look back and what am I looking for? Negative says less than 0. You're looking for something less than 0. So after all that effort, you can't use it. The sad thing would be, I hope it's not going to happen, sometimes you'll test the entire number line, nothing works. I'm going to jump into the next one. Maybe it'll work. I'm trying -2, guys. Here goes. Same process. We're going to go back and replace x by -2. Just the x. A negative times a negative gives me a positive. +2, subtract 3. I know it's a -1. I'm just concerned about the sign. You got to show me the signs. Replace this x by a -2, my test number. Of course, it's negative there. Squeeze that in. And a -2 plus 1 is a -1. Another negative. Okay, if we did that right, guys, we got a negative over a positive. What is a negative over a positive from algebra? Negative. Is that right there indicating that's what I want? Yes. That says you have discovered by sign analysis this interval works. Now let's try it right next to it. May also work. I don't know yet. I haven't tested. I'm testing -1/2. Okay, I'm going to put a -1/2 in here, guys. Replace x by a -1/2 in the numerator becomes negative times negative, +1/2. So it's a 1/2 subtract 3. That's going to be a negative. You do the math. And -1/2 replace x by -1/2 there. Of course, it's going to be a negative. I'll squeeze that in. A second factor down here, put a -1/2 in. -1/2 plus 1 gives me a +1/2. That's going to be a positive. Now that one says I have a negative over what? A negative, which is a what? Is that a positive? Am I looking for a positive? No. Can't do it. Can't do it. Maybe what I've shaded in may be it. I haven't finished up testing though. That it's not gonna work. Let's try 6. Here goes. Put a 6 right here. That's a -6. Subtract 3, that's a -9. I'm just concerned about the sign. Put a 6 here, of course, it's positive 6 for the x. Put a 6 here, 6 plus 1, 7, another positive. Will that work?
Yes.
Yeah, because negative over a positive gives me altogether what? Negative? And that's what this symbol says you're looking for. I'm allowed to now shade this in. That's another interval that works. Now, before I leave it and ask you guys to help me put this in interval notation. Nice problem for you to start out today. Whew! I noticed when I had the problem written on the board, this says less than or what? Equal to. I placed my 3 critical numbers. Can anyone tell me, of those 3 critical numbers, notice I haven't done anything with them yet, -3, -1, and 0 came from me finding critical numbers from this. I said each one equal to 0, find a critical number. I see 2 of those 3 that I cannot let happen. Can anyone tell me, of the 3 critical numbers, which 2 can I definitely not let happen? If they can't happen, I'm going to place an open circle. Go for it.
We can't use -1 and 0.
Okay, hang on now. So you're telling me, Professor, you cannot let x be a -1, so I'll be open, and you cannot let x be 0. If you replace x by 0, you get a 0 denominator, which you can never have. He tells me if I replace x by a -1, also down here, -1 plus 1 gives me another 0. So those 2 cannot happen. Now, I have the equals mark here waiting for something. Do you think I can include the other critical number, -3? Do you think because that equals mark is there, maybe this one will be darkened in? And the other 2 remain open? Yes or no? Does that equals mark saves this, where I got -3? So can I include -3? I see the equals mark there. Now, if the equals mark were missing, can anyone tell me before I leave it, if that were missing, what now would happen? All 3 would be open. This saved the top part, -3. I can include that. Now, can someone in my class tell me, there's the picture. Tell me in interval notation, what does this look like? Can anyone describe this interval right here for me? Because that's going to be the answer to the problem up here. What does that look like in interval notation? Anyone? I'll start you out. Bracket, -3. Up to what? -1, not included, parenthesis. Union. Now, name the piece down here, because I also shaded it the best I could in red there. It also worked. Can someone describe in interval notation what this looks like? Parenthesis, 0 through what? Infinity. A calc instructor would walk in and say, oh my goodness, I love that. Where's my do it in calculus again? A little demanding. Sign analysis. Okay, so I thought I'd bring that in as we talk about this. Got something really interesting coming up here that's going to be shot soon here. Oh, here's my next one. Last one probably. Letter C on this type. Guys, I told you I go online to these universities' websites. UCLA, USC, I've been there many times. And sometimes a professor from that particular college, USC, UCLA, Dartmouth, Harvard, wherever, I don't care where it is. I like to search. And some math professors will post their grades or post their test from UCLA online for their, for their students. Students who are taking the test, so they just post the test along with the answers. And Ramsey's looking at that. And then when I look at it, I said, wait now, my students at SMC should be able to do that problem I saw on that calc test. And here's what I saw. It came down to this. I think it's exam number 1 that I saw on the calc test. They had this. And this. Make sure I have everything copied out correctly. That was on the, I forgot which website it was now. It's on the first math, they didn't call it math 7, it was a calc test. On their calc test, the first calc test. It says, solve this. There's an inequality. It's a mess. But I'm going to try to approach it like I did that last one, which took a little bit of time. I'm going to draw a number line and try to use sign analysis. And in fact, after I looked at the solution that the professor posted, that's what he or she wanted. And if I do that, guys, right quickly, this one's in pretty good shape. Can anyone tell me? But you're going to love sign analysis. Sign analysis can be used tonight in the quiz. Sign analysis is nice. Can anyone just quickly look at this and tell me, I see 3 critical numbers that need to be placed on that number line, and then we'll start testing. Can anyone first tell me the 3 critical numbers? Yes?
0, 1, and 4.
Love it. 0, tell me again.
0, 1, and 4.
I'll take the 1. I think it's a -1, isn't it? I'll take 4.
Negative
I think it's -1. Is it true, guys?
Yeah.
That's what he wanted, or she wanted on that test. Now, let's go ahead and get this out of the way before I start testing. There's my critical numbers. Which of those 3 can I not let happen? Yeah, the -1 would make a 0 denominator, and I know that cannot happen. The other 2, because of the equals mark, can be included. So these 2 can be darkened in. Please, don't make math hard on yourself here. Now set up. Now comes the testing. Go ahead.
So what happened? -1?
If you replace x by -1, you get a 0 denominator.
Oh, I see, okay.
You can never have a 0 denominator. Now let's test out here, 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 and here. I see why they placed this on their first calc test. Out to the left of -1, guys, we'll try -3. That choice is yours. Between, and we'll try -1/2. Between 0 and 4, I'm going to try 2. Now to the right of 4, I think we'll try 7. Those are up to you. Now all you need to do is go back, crunch out some signs for me. You're going to go back here. Here we go. I'm going to replace first by -3. Let me do this in red. -3 squared, positive 9. My second factor, -3 subtract 4, that's a -7. Denominator, -3 plus 1, we know that's a -2. What is that all together? It's a negative over a negative, which is going to give me a what? Positive. Does that indicate that's what I'm looking for? Yes, you have discovered this works. Beautiful problem. Now in between, -1/2. Okay, what -1/2 squared is a positive, of course, positive 1/4. -1/2 subtract 4, that's a -4.5, it's negative. And for my denominator, put a -1/2 in, -1/2 plus 1 is a positive 1/2. Guys, all that together is negative, which I can't use. It says I'm looking for something greater than 0. So if it's a negative, you can't use it. Out to the right, between 0 and 4, I'm trying to 2. 2 squared is 4, positive. 2 subtract 4, negative. Denominator, 2 plus 1, positive 3. Let me step back and make sure I did all that correctly on top of the board here. Guys, all that together is? Negative. Is it negative?
Mm-hmm.
If it is, I can't use it. Did I do that correctly? I can't use it. Maybe I can use the 7 or out to the edge there. Let's try 7. 7 squared, of course, is 49, positive. 7 subtract 4, positive. 7 plus 1, which is 8, positive. Is all that together positive? Was that what I'm looking for? Yes. So that says, hey, this works. Now there, shaded in, is your answer. I'm happy as an instructor. Oh, am I happy if you get to that point. Of course, I'm going to ask you to place your answer, though, in interval notation. We've discovered what it is. Now, I need a clever, clever student. Can someone tell me? I have quite a few clever students in this class. Can anyone tell me what that first shaded part might look like written in interval notation? I see a hand going up. Yes, Billy.
Put negative infinity, -1 in parentheses.
Love it. Hang on just a second. Now, union. Now, I need clever, clever, cleverness. Can anyone now tell me what's happening now? Go for it.
Is it 0 inside of brackets?
Okay, you say Professor Zero also works. It's not an interval. It's just 0. I prefer you write like this. Just put it inside a set all to itself.
What do you call those?
Ah, beautiful. It's just an element. It's one element that works there, 0. So I'm not going to use interval notation. Now, down to the right of 4, I will use interval notation. What do you think down to the right of 4 looks like?
Bracket 5.
Not bracket 5.
Bracket 4.
Bracket 4. Through infinity. And that's the answer that that particular professor on that particular university calc test, first calc test was looking for. Then I looked on the side to see how many students responded correctly and how many students did not respond correctly. I was shocked. Not too many got it. That was the first test. Yes?
Why doesn't the negative infinity have a bracket?
Oh my goodness. If you put a bracket on something, that means you can include it. You can't include infinity. Infinity is not a number. So never, never, never place a bracket on the infinity, negative infinity or positive infinity. You can't include it. That's what a bracket implies. You can include that. Never. Guys, that makes sense? Powerful. Sign analysis, powerful. In fact, I see ways you can use sign analysis even tonight on the quiz to make things work out for us. So I thought we'd do that. I think it looks nice. It leads you into where I'm going to go here. And that is, hang on just 1 second here. Beautiful. Now you guys have a handout on functions. Let's see if I'm ready for it. I am. Now we'll just point this out. You'll get a copy of this as you leave. This is a review for the exam next Wednesday. These are the types of problems you'll see next Wednesday. And you'll get a copy of it. And the answers. In fact, in many cases, not only the answer, the solution. I worked it out for you, like I do here in class, to get you ready for next Wednesday, because next Wednesday is the big day for your first test. Then on the back of one of those pages is something that looks like this. Wait till I show you what's happening. Wait till I show you what's happening. And you'll see this when you finally get a copy of this. Guys, I wrote this down as this to continue and move on to something else, functions and so forth and so on. I thought I'd better do this first, which I'm going to do right now in a second. Yes, here it is. Let's move into part 2. And I'm leaving this. We'll give you this. We'll draw a graph for you. I'm going to say the graph looks like, just roughly, something like this. have on this graph, I'll use different colors here, I have a parabola to sketch. Yeah.
Is this still like considered inequalities?
Hang on, that's where I'm getting to right now. It is. I have this sketched. That's a parabola. You knew that when you walked through the door, first day I met you. Then along with that, I did this for a reason. Wait till you see what happens. I drew a nice straight line. And they intersect. I gave you the intersection points for a reason. I said the intersection points are right here. They intersect at 2, 4. And the other intersection point on the other side, looks like I have it to be, yes. -1, I called it, intersection here. -1, up 1. So out 2, up 4, intersection point of the blue and the red, and -1, up 1, intersection point again. Then I've named the functions. Guys, the blue one is going to be a quadratic, and I meant very simple. The blue one has this name. It's f of x equals x squared. I'm using the function notation. We'll go ahead and call it a function. The line in the red, I named as, let me step back and look at it. Yes, looks like, hang on. Y or f of x equals, I'm trying right now, we may change this a little bit, but it looks like it's going to be this. Looks like it's going to be f of x is equal to, or g of x is equal to x plus 2. Hang on, the red one. Let's call it g of x. I may have changed up a few things here, guys. Hang on. Now, you're going to help me out. Let's say that's what you have. You have a parabola, you have a straight line, and they're intersecting. You say, Professor, where's this going? I just had one of my students say, Professor, are you still talking about inequalities? Or are you just having a bad day? Are you still talking about inequalities? Now, first off, before I jump in and show you, I am. Wait till you see what happens here. Guys, if I put a 2 here, I get a 4. Is that true? If I put a -1, I'm supposed to be on the blue one there. If I place an x with a -1, right here, I get a what? 1. So are those points okay? They're supposed to be also on the red. They're on both. So I'll replace x by a -1 here. What's a -1 in the red? -1 plus 2? 1. If I go over here, 2 plus 2 gives me 4. Does everyone agree?
Yeah.
Woo! Wait till you see what's going to happen. Here we go. Question. I'd like to solve this. Thank you. Now, don't go out and tell other instructors and students what you see in this class. They're not going to see it. You're going to see it. I'd like to solve that inequality. I'm back on inequality now. You say, Professor, you drew that cute little sketch. What are we going to do? Well, first we'll solve this like we've been solving, like you'll solve tonight in the quiz. You'll say, wait, this is a quadratic, Professor. Let's make one side 0, which is critical. And then do what? A factor, or use quadratic formula on that quadratic. I think it factors to save me a little time. You guys who are strong at factoring, I think it factors into that, does it?
Yep.
Then I want less than 0. This is an inequality. Then I need my critical numbers coming out. And by the way, can anyone look at this right now and tell me what are my critical numbers, I'll place on the number line like I did these, and then I'll start testing. Anyone have an idea of what are my critical numbers?
0 and negative
2 and negative 1. And they're both supposed to be open. I don't see an equals mark to worry about here. You guys agree? This is not what we've been doing all this period of time so far. To the left, I'm going to test negative 3. In between, I'm going to try 0. Out to the right of 2, I'm going to try 5. Now help me out. You saw what I've done before. I'm going to replace these x's by negative 3. Negative 3 subtract 2 is a negative 5. I'm just concerned about the sign. Second factor, negative 3 plus 1 is a negative 2. And a negative times a negative gives me a positive. Is that what I'm looking for?
No.
Nope. Can't use it. In between, I'm trying 0. 0 subtract 2 and that factor gives me a negative. 0 plus 1 gives me a positive 1. Positive. And a negative times a positive gives me a negative, which just says that's what you're looking for. Looking for something less than 0. So this is negative, works, so you are allowed to shade. Out to the right may work. I'm going to try 5. 5 subtract 2 is a positive 3. 5 plus 1 is a 6, positive 6. I got positive times a positive. I don't think that's going to work. Is it, guys? No. Is it? No. So right now, with what I've been doing here, you'd say the answer is, Professor, what worked? I'm placing an interval notation, parenthesis, negative 1 up to what? 2. You say, Professor, why'd you draw the sketch? You thought it was cute. That's why I drew it. If I had, now look at the sketch. If I'm clever, you would get that answer that we just did. Here's the answer. We went through all this, which we should. And the answer's here. The answer is, if you look at the graph, it's right there in front of me. Why would I place that graph? Okay, let me give you a translation first. This says, we've already finished it up. We got the answer. This says, when is my blue graph, that's my x squared graph, the blue one, when is my blue graph below, less than, the red one, the line? So I'd like to know on this sketch, when is my blue graph, the parabola, below the red line? This means below here on the graph, on the grid, less than. And guys, if I shade where that happens, when is the blue below the red? Please tell me, is it below the red here? On the blue. Is all that below the red? There's the answer. And when is that happening? From what? Negative 1 over to what? Same answer. Same answer. I see some looks on faces like, are you kidding? Professor, please graph these for us. When you ask us to do one of these, professors, please supply the graph. And I can just look at the graph and see where it's below or above. And we're finished. Isn't that cute? That's why I was doing it. We're right back into inequalities, except I did it by this time graphing. Now, before I take questions here, I'm not going to do another solving, but suppose now it had looked like this. You want to solve this inequality. And I did not want to go through this routine, which of course we should if you have to, but you have a graph on the side. Now what does this mean? Now you're looking for when is the blue above, greater than the red. Now can someone describe for me, maybe I should use a different type of marker here. When is the blue above the red? That's what now I'm looking for if we can. Let me try green. Guys, please tell me, is the blue above the red? Oh boy, this will erase it. Here, another green marker. Is this piece right here above the red? And is there another piece above the red? That true? Those little pieces? Now, can someone tell me in interval notation, when is that happening? And I'm not going to verify it, confirm it by going through this process again, but it would work this way, using sign analysis. Now, tell me, I see hands going up, yes, in the back there.
Minus.
Okay, first get this piece out of the way for me here.
It's minus infinity to -1.
-1, thank you.
And
Hang on. Union, you're saying that the other piece?
from 2 to infinity.
There's your answer. Now, if you did by sign analysis, like I've been doing tonight, you'll get the same answer. Would it help if I should supply a graph for you on the test next Wednesday?
Yes.
Wouldn't that be cute? I think for one I will. I think for one of the questions on the exam next Wednesday, I will supply the graph. And ask you to solve that inequality just by looking at the graph. You don't have to show me any work. Just look at the graph. And if you miss it, I'm gonna stop you and say, did you look? Did you not see that graph? Don't you dare miss that. Just look at the graph. Isn't that an easier way to do these? Much easier if you have the graph in front of you. The trouble is the graph in itself. Some students may not even recognize that this right here should have been a parabola. I think most would. And this one is in the form of mx plus b, has a slope and so forth, the y-intercept, which we'll cover later on. Graphs into a nice straight line. But I'll supply the graph for you. I thought we'd do that. You guys any concerns right now at this point? Yeah,
I've got a question.
go for it.
Just as far as your notation goes, the union symbol, why are you doing it that way instead?
Just to show you there's another section to worry about.
Okay,
Now, if you did this, I would not count it wrong. Some textbooks will do this. They'll separate these two by a comma and say those two intervals. I've seen that. That's true too. I like the union symbol myself. This answer, union, another piece. Okay, guys, anything else? Now, if you don't walk out of here tonight, I know you got a quiz, but if you don't walk out of here tonight and this did not do something in your mind, we've got some issues. Whoa, we don't want to have any issues. That right there should have clicked, and if I were a beginning student or a student who had some experience behind me, I would say, are you kidding? I like that. That makes all kinds of sense. Rather than going through sign analysis, if the graph is provided. Okay, guys, I did that for you. You'll get the handout with that on it shortly. Now, though, I'm finishing up now. We have a quiz tonight. And the break is supposed to be at what, 6:10? You're supposed to get a 10-minute break? Jeez. 10? Yeah, it's okay. That means you come back at 6:20. And then I'll give you the rest of the time. Let's see, is that going to be enough time? 6:20. Yeah, class doesn't end until what, 7:25? Oh my goodness, yes. This little short quiz tonight. Should be plenty of time. We'll find out. I'll give you plenty of time. Don't worry about the time here. What I need to do, though, is this. Part 3. We're back to functions. Now, before I get back into it, I had a student, I forgot my student's name, who read for us. Ramos, where's Ramos? Ramos is not here. I think I had another student. Ramos, you're here. Did you get the information about the textbook? It didn't work?
Oh, yeah, I did, but.
Oh, yeah, I sent you a message. Yeah, it finally worked, right? That's a headache. I don't know why we're making such a headache to get the textbook, the ebook. I had a student, though, I think in the back there, read for us the definition of a function. I think. Didn't we?
Yeah.
And then we looked at it. Now, can someone tell me, I may ask him to read that little short definition again here shortly, but can anyone tell me, before I jump into what I gotta do, why might I notice that blue graph which represents x squared. Can anyone tell me right quickly, why might I know that is a function? In fact, I use the f of x notation based on his definition or something you might bring into class with you in the back there.
Because the red line only intersects once.
She's a professor, thank you, she's a professor. If you have the graph provided to me, I'm going to just use something called vertical line test. And then I'll pick up his definition. The vertical line test says anywhere on that blue graph, guys, anywhere on that blue graph, if you draw a vertical line, I know I've got shade in here some, but right here, you find one point of intersection with that parabola. If you draw a vertical line somewhere else of your choice, you always just get one point of intersection. So that's a function. So that vertical line test, if you see the graph, could be used to quickly see if it's a function. Is, or was, my red line also a function? Would it also pass the vertical line test? If I pass the vertical line anywhere I wish, I just get one point of intersection with the red line. So they both are functions. And that takes me right back into where we left off, I think, on Monday, the functions. Now that said, here we go. I'm trying to recall the handout. You guys have a handout here. Oh, I see it right here. Oh, do I ever see it? Right? I think I gave you, right at the top it says functions, section 1.1. Guys, here's what I gotta do. This will probably take us up to break time. Okay. I'm going back to where they gave you a function on this handout. They gave us this, f of x is equal to a negative 2x squared plus x, subtract 1. And then they ask you to find f of certain numbers, find some values here. I don't think I've done all of these. I think I ran out of time on Monday. I don't think you guys can remind me, did I have time to find, for an example on that handout, I think one of those is f of radical 2. Did I do that one? No, we're going to do it right now. Okay, so inside there, they could throw something at me that may look strange, but it says find f of radical 2. And I know what that means. That means x, professor, replace the x with radical 2. That's what it means. So it's a negative 2, radical 2 squared, plus radical 2, subtract 1. And then you have to simplify it. Please, guys, what is radical 2 itself squared? Is that 2?
Yeah.
It's radical 4, which is 2. And then negative 2 times 2 out front, the first term is negative 4. I still got this. Still got this. Put some like terms together. In other words, my numbers, negative 4, negative 1 is negative 5. Plus this. And you stop. There's the answer. I wish you could do more with it, but you can't. There are little like terms down there. That's all I can do with it. Next one, which I don't think I had a chance to do, let's call that number 1. Number 2, and you guys can remind me, did I get a chance to do f of x plus h? Did I do that one or not? No, we need to do it. And keep in mind, I can throw anything inside there on that exam next Wednesday. It says merely go to the function given and replace. If I do, this one looks like this. And I gotta be very careful when I put those in and see if you guys will agree. Went back to my original function, and every x I saw, I replaced it with x plus h. That's what they asked me to replace it with. Now, the simplifying may throw you a little bit. Be careful. If I want to simplify this, this is negative 2. Now, can I hear from a student, what do you think x plus h, quantity squared, looks like it expanded out? Go for it.
X squared
Okay, x squared.
plus 2xh
Thank you. And
h squared.
look at that. Exactly 100% right. And then, of course, on the end, you still got this, which is going to be nothing. And subtract 1, still got that. Next step, to try to simplify further, I see a distributive property, distribute that -2. And guys, I'm gonna bring it up here so everyone can see it. A -2x squared, I gotta get out of your way here, minus 4xh minus 2h squared plus x plus h minus 1. Let me step back and look at it and see if we did all that correctly. Do you guys agree? Please tell me, are there any like terms? That's sad. That's the answer. You can't do anything else with it. This is it. I don't see any like terms to put together. That's a long answer, but that's it. That's what they asked me to do. That's it. Done. Now, that has been taken care of. You sort of have an idea there. Now, I gotta watch my time here. Got 10 minutes. Part 4. On the handout, it's asking you to do this. Find the domain. First one looks like this. F of x is equal to 3 subtract 16x squared. Now guys, when you use the word domain, what's that associated with? The x. They're saying, please look at this. Don't do anything, but just look at it. But are there any restrictions on what I can replace x by? Or may I, at this case, just throw anything I wish at x and it should work? So that means this one's open, the domain's open on this one. You may replace x by anything you wish, not run into trouble. And that domain is now expressed as, here goes, D for domain, all real numbers. I'm gonna write mine like this. And if you wish, of course, that strange looking R there. All real numbers. Negative infinity through positive infinity. It's open. So I don't care what you replace x by, you'll get an answer. Yes? I thought I saw a hand go up. Someone try and come in? Ghost. Guys, this was open. Everything works. Next one, watch carefully. On the handout it says now do the same with this function. Don't solve it, just look at it. G of x is equal to this, x subtract 3 over x squared subtract 4. I want the domain. Now, please tell me, now, with all the experience, even with just me here since class started, are there some numbers that I cannot let x be?
Yes.
Like what? 2 and -2. I'll put it like this. All right, like this, guys. X cannot be equal to plus or minus 2. Now, can someone, that's the answer. But I'll more than likely ask you, please put it in interval notation for me. Can anyone think they can write this in interval notation and show me that you're telling me I cannot use a -2 and I cannot use a +2? Does anyone have an idea? I see hands going up, yes.
Would it be negative infinity to -2?
Oh, hang on, I like that, hang on. Tell me more.
Union 2 to positive infinity?
You know what, I love that too, but I think you're leaving something out. I'll go ahead and put that down though. Absolutely, but I think there's one part left out. I think I need another interval, and I'll show you why here shortly to make it complete. Yes?
Would it be parentheses to with -2?
What, -2? Tell me again. -2 up to 2. Like this. Now see why I took that extra 1 there. If you're telling me back up here, that's just thinking about it visually. This is not sign analysis. You're telling me earlier, Professor, you can't use those 2 numbers. This is not sign analysis, it's just a visual. You can't use those 2 numbers. Well, what can I use? You can use all these, which is that interval. You can use all these, which is this interval, and use all these, which I think was given to me here, as that. And that's why I took 3 separate intervals to describe. You cannot use a -2 or a +2. Well, what can I use? Everything else. But you can't use -2 or +2. Letter C. Looks like this. Ah, yes. H of x is equal to square root 2x subtract 1. I don't want you to solve it. Some students will jump in and say, oh, Professor, square both sides. No, that's not a solving problem. I'm just asking what is allowed to replace x by. And I can tell you right now, just randomly, if I tried to replace x by 0, I'd run into trouble on this function. I want to know what can I replace x by. Now, does anyone have an idea how to come up with the domain, what's allowed to replace x by? And I will tell you there's an infinite number of numbers that will work. And there are some that will not work. Yes?
It can't be below 0.
Okay, cannot, you mean the inside part?
X cannot be a number below 0.
Okay, so x cannot be less than 0.
Less than or equal to 0.
Okay, let's think about this. I'm trying a number there. Less than 0, right? Like a -5. I can't use a -5. But if I replace x by -5, this becomes a -10 minus 1. This is a -11, and it's underneath the square root. That's out. You can't do a square root of a negative. So she says, Professor, you can't use anything less than 0. I tried -5, it didn't work. Now suppose I tried 1/2. Just at random. I'm going to replace x by 1/2. I replace x by 1/2, guys, right here. 2 times 1/2, when the 2's cancel, if I replace by 1/2, 2 times 1/2 is like what, 1? And 1 subtract 1 gives me what underneath there? And is there a square root of 0 possible?
Yeah.
Yes. So 1/2 works. Will 1/4 work? I said 1/2, how about 1/4? If I replace x by 1/4, just at random, 2 times 1/4, I think is 1/2. And 1/2 subtract 1 is a -1/2, and I cannot have a negative. So we got everything to the left of 0. She's telling me, Professor, cannot be used. Now I tried 1/2. 1/2 can be used. There may be others. Can anyone give me another number at random that might work? I tried 1/2 and it works. Are there some other numbers that may work? Before I actually jump into it and find what they are? Would 3 work? Just at random? Could I replace x by 3? If I replace x by 3, that's 6 subtract 1, that gives me a 5. As long as it's positive underneath there, the square root's possible. Is that true? So I'd like to know, where are all of them? Well, here's the best approach, to find all of them. This part, guys, all that for a square root to make sense must be what type of an expression before you can do a square root on it. Positive, or it could be 0. You can do a square root of 0. I will express that as this. The inside part, to make sense here, must be that, or you cannot do a square root on it. And then you got to solve that inequality. You guys agree with that right there? Now if I solve this inequality, easily done, you're going to end up with 2x is greater than or equal to what? 1? X is greater than or equal to, looks like what? 1/2, there's your domain. anything to the right of and including 1/2, I think I tried 1/2 myself and it worked. Anything to the right of and including 1/2 will work. Now if I say, please place that in interval notation, can someone, before we close down for a break here, what does that look like in interval notation? I see hands going up. I see the same 2 hands going up. My goodness. Who else has an idea? What would that answer look like in interval notation? That is the answer, but I'd like to put it in interval notation. Okay, go for it.
Bracket,
Bracket,
1/2,
1/2
infinity.
through infinity with a parenthesis. There's the answer. Now before I close down, someone tell me, it's not on your handout. If this had been, I'm going to just do a quick little glance at it. If this had been this, not a square root, but a cube root. Now, do I still have those same restrictions? Is my domain the same? For the square root, which we did earlier, is this still true for a cube root? No. Can I have a negative number underneath a cube root and it makes sense? If I have a cube root and you say, Professor, you can't place a negative underneath there. That's for a square root. Is it possible for a cube root?
Yes.
Yeah, the cube root of -8 is possible. It's -2. And in fact, for a cube root, I could have placed even 8. That's a +2. Square root, I could not do that. So what would you say if it were a cube root, what would the domain be? All real numbers. A square root, a 4th root, a 6th root, those even ones, you can't. Would not be all real numbers. Guys, that makes sense? I'm watching my time here closely. I see it's break time. I'm sure you see it's break time also. It's break time. So let's take a 10-minute break. And we'll get that quiz started here soon.